Vaitarna Bridge, connecting Safari with the major state highway number 4 and subsequently to the Mumbai-Ahmedabad highway, was constructed during the years 1985 and 1988. The bridge consists of 8 spans. The main spans are 45 meters each, while the end spans are 25 and 30 meters respectively. The total length of the bridge is 325 meters. The foundation of the bridge is a well foundation and the substructure consists of 7 RCC piers, P1 to P7. The superstructure consists of PSC box girders. The width of the carriageway is 7.5 meters. This bridge has been carrying all kinds of vehicular traffic for more than 27 years. During a routine visit to the location in December 2014, a vigilant PWD engineer suspected that the railing above the pier P5 was tilted. After detailed observation, it was found that the pier P5 was tilted by about 15 to 20 centimeters on the upstream side. The neoprene pads were also displaced and the superstructure was dislocated. A zigzag vertical crack was developed in the well up to the well cap. The width of this crack was nearly 30 centimeters at the bottom and 4 to 5 centimeters at the top. Considering the serious nature of the problem, a study committee was immediately formed by the government of Maharashtra to inspect the cause and suggest a possible solution. After detailed observation and analysis, it was concluded that the problem had been created mainly due to the sand dredging carried out over a period of many years. This had eroded substantial part of the base of the well foundation of P5. Only 30% of the area of the well bottom was resting on the rock and it was in a destabilized condition. Also, the depth of the water had increased by 10 to 12 meters. Alternatives were evaluated by the committee before they zeroed in on a proper remedial measure. The committee of experts had suggested construction of a new well with portal beam and then transferring the load on this new supporting structure. However, we realized that it was almost impossible to construct a new well. Therefore, we held discussions with the committee again. Finally, it was decided to construct piles on both sides of the existing well, along with a portal beam, and transfer the load on this structure. When the action plan was finalized, the first hindrance was the stagnant water of 18 to 20 meters deep around the place of work. Simultaneously, this being a backwater, high tide and low tide also affected the work. It was important to assess the status of the well, P5, and stabilize the same before the commencement of actual work. Therefore, an underwater survey was carried out with the help of expert divers. A scheme to stabilize the well was designed and implemented. The piling work commenced after that. The underwater survey indicated that there were gaps in about 70% of the area between the bottom of the well and the ground. It was important to stabilize the well foundation of P5 to avoid further tilting before the actual rehabilitation work could commence. Due to the depth of water of about 15 to 16 meters and tidal effect, it was a great challenge to work under these extreme conditions. It was possible to work only for 3 to 4 hours a day, considering high and low tide. Also, the velocity of water, which is about 4 to 5 meters per second, was an impediment to work. The scheme prepared for immediate stabilization of P5 was as follows. Initially, the gap between the well bottom and the ground was filled up by inserting wedge-shaped precast M40 RCC sleepers of required sizes in layers. The remaining gap was filled with MS plates. The loose material on the sides was cleared with air compressed pressure. Next, RCC ring beam of size 500 mm by 500 mm was cast underwater with quick setting adhesives. In the next stage, cement grouting was carried out at the bottom of the well with required pressure using mechanical equipment. The depth of the water was about 18 to 19 meters. Hence, expert scuba divers had to be engaged for this work. The stabilization was done to stop further tilting of the existing well and also to bring the existing tilting within the permissible limits as prescribed by IRC Code 78. After this, it was time to commence the rehabilitation work so as to provide alternative support to the superstructure and abandon the existing pier well. Accordingly, it was decided to provide RCC piles of 1200 mm diameter on both upstream and downstream side of P5. A total of 12 such piles were planned, with 6 piles on each side of the pier well till the height of well cap. The average height of piles up to cap level was about 17 meters, while the socketing depth in rock was approximately 5 meters. Thus, the total height of a pile was about 22 meters. While socketing, it was important to keep the constant pace of execution, as due to hard rock, a pile excavation was about 20 to 22 centimeters per day or night during high tide and 25 to 30 centimeters per day or night during low tide. Hence, it took almost 15 to 20 days on an average to achieve 5 meter socketing depth for one pile. Considering the urgency of work, the piling was continued even during monsoon, except on high flood days. The pile cap was of suspended type with depth of 1.8 meters and weight of about 500 metric tons. The form work was designed in such a way that it provided supports from the pile itself. 52 steel bars of 32 mm diameter were used for reinforcement of piles. Circular monolithic RCC columns of 1500 mm diameter and 2250 mm height were cast over the pile cap to support the portal beams. Rectangular portal beams were cast except in the middle portion of the existing RCC pier.
सगळ्या पायलिंग पूर्ण झाल्यानंतर जो
After completion of the piling work, it was essential to lift the main girder of the bridge so that concreting could be done below that. This was the most important and delicate part of the whole process. We used mechanical jacks of high sensitivity for this purpose. Transferring the load after lifting of the girder was another sensitive, tricky part of the work. The superstructure was lifted by hydraulic jacks and was temporarily supported on portal beams. Later, the existing RCC pier was dismantled so as to cast the remaining portion of portal beam. After curing period of 28 days, the pedestals for bearing were cast and neoprene bearings were provided. Finally, the superstructure was lowered on bearings. During this period, the inspection of superstructure and external pre-stressing was carried out using different tests. Necessary repair works were carried out simultaneously based on the test results. All this was easier said than done. The challenging work of piling was continued even during rainy season with the help of marine work experts and scuba divers. The heavy rains in July 2016 led to the flooding of the Vaitarna River, which caused overtopping of the pontoon, leading to heavy financial losses. But all stakeholders were determined to accomplish the task. Everybody in the team, including the design engineers, PWD engineers, project consultant, and all the contractors worked in close coordination. The day-to-day monitoring, weekly progress reports, visits by experts, and a single-minded devotion to quality control naturally led to the completion of this challenging project with flying colors. The observation of one vigilant engineer was picked up by the top authorities at PWD with all seriousness. The right thinking and swift action on their part has not only strengthened the bridge, thus increasing its longevity, but has also averted a possible mishap. For the Palghar Division of the Public Works Department of the Government of Maharashtra, it may be one more task accomplished, but for the people, it reflects the deep-rooted commitment to public service. Public Works Department, adding newer benchmarks to the glorious history of more than 150 years.